Hello students, this is our third lecture of the Process Control Techniques Unit 3. In this lecture, we are going to study the P chart and NP chart. So first we start with the P chart. I have told you earlier lecture in the live classes that is the fraction when we apply the P chart, NP chart and C chart. When we apply P chart, P chart is applied whenever the fraction of defective is given. NP chart applies when the number of our defective is given, and the C chart apply at the number of defect per unit is given. Right? So first we are starting with the P chart. Control limits of the P chart. First, central line. CL is equals to P bar. What do you mean by the P bar? P bar is equals to sigma P upon M. How we can find the P? P is equals to D upon N. So D is equals to defective. Right? Then lower control limits. Lower control limits is equals to P bar minus 3 under root P bar minus 1 minus P bar upon N. There is a lower control limit. Now upper control limit is equals to P bar plus 3 under root P1 minus P bar upon N. There is a control limit for the P chart. Now control limits for a NP chart. Central line. Central line CL for the NP chart is equals to NP bar. Lower control limit is equals to NP bar minus 3 under root NP bar 1 minus P bar, and upper control limit is equals to NP bar minus 3 under root NP bar 1 minus P bar. There is a control limit of the NP chart, and these are the control limits of the P chart. You can see the exact difference between P chart and NP chart. The P chart is chart of the fraction of defective, where the NP chart is the chart of number of defectives. The calculation are difficult in a P chart. The calculation are relatively easy. The P chart can drawn if all the sample are not equal in the size, but NP chart can be drawn only when the samples are of the equal size. Now we are solving the illustration number 7. Draw a P chart from the following information. Decide whether the production is under control or not. The sample inspected item 200 is given. Out of defective item 8, 12, 2, 20. Various defective item is given. So first let's start the illustration number 7. Samples 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? Here the defective items in number is given, but we have to find out the P chart. So we have to find out the fraction of defectiveness. So first we have to find out P. How we can find out P? P is equals to D upon N. D stands for defective items. So D, let's put the D. 8, 12, 2, 20, 10, 15, 6, 20, 13, 9, 16, 10, 13, 6 and 8. Let's find out P. For N, all the samples N will remain same. 200 unit are examined, right? So 8 upon 200. It will come 0.04. Then 12 upon 200, it will come 0.06, then 0.010, 0.1, 0.05, then 0.075, 0.030, 0.1, 0.65, 0.045, 0.080, 0.050, 0.065, 0.030 and 0.040. Let's total off all the p values. 0.04, 0.06 plus 0.010, 0.01. Total of this, it will come 0.840. Now we have to find out p bar. P bar is equals to sigma p upon m. So 0.840. How many samples are there? 15. So 0.84 divided by 15. 0.056. Now we have to find out minus p bar. 1 minus 0.056 is equals to 0.944. 0.944. Let's find out the control limits. Control limits of P chart. Central line is equals to P bar. P bar is equals to 0.056. Now, lower control limits. P bar minus 3 under root P bar 1 minus P bar upon n. So, P bar is equals to 0.056 minus 3 under root P bar is equals to 0.056 and 1 minus P bar is equals to 0.944 upon n. N is equals to 200. Right? Let's solve this. 0.056 minus 3 into, let's find the value of this. 0.056 into 0.944 divided by 200, it will come 0.0026 and it's under it. It will come 0.00162. 0.056 minus 0.04877. Answer will come 0.00722. Answer is given 0.0725, but it is okay, something points will differ. So lower control limits is 0.0722. Now upper control limit, P bar plus 3 under root P bar 1 minus P bar upon n. So we can 0.056 plus, we directly put this value, plus 0.04877. Answer will come 0.1477. So upper control limit is equals to 10477. There is a lower control limit 0.0722 and upper control limit is 0.10477. Let's start with the chart. This is the format of the P chart. On x-axis we have taken the sample. On the y-axis we have taken the P. So what is the lower limit? Lower limit is 0.07. And so we have started with the 0.05. And we go beyond the upper limit is 10.104. And so we goes to the 0.105. Right? Let's start with the placing the points. We have to place the points on this basis. For the first sample, P is 0.04. First we have to write down the limits. Control limit is 0.056. 0.056. So it will come over here. Central line. Then lower limit is 0.07. So it might come here. Lower control limit. Upper control limit is 0.104. So we have to put 0.104 over here between 100 and 105. Upper control limit. Now we are placing the points for the one 0.04. So it will come over here. Sorry, 0.04. Then 0.06. Then 0.010. So for 3 it is here. Then 0.1 for the fourth. 0.1. Then fifth 0.05. It will come here. For the sixth 0.075. For the seventh 0.030. For eighth 0.01. Over here. Now at the ninth 0.65. Then 10th 45. For 11th 0.80. Then 0.50. Then 0.65. Then 30, and then 40. Let's join all the points very quickly. After joining the points, the graph will look like this. Let's see the process is out of control or in a control. So no points is on the beyond the upper limit and below the lower limits. All the points are within the control limits, right? This is known as, this process is controlled, under control. See how beautiful chart is? Look like a heartbeat. Now we are solving the illustration number 10. From a factory producing Pitson rings, sample of the 200 rings are taken daily. The record of the defective rings is given below. Draw an appropriate control chart and report on the state of the control. So date is given and defective ring is given. So it's a number of defective item is given. So we have to apply the NP chart. If it is a fraction is given 0.5, 0.10. So in this chart we can draw a P chart, but in the number of defective rings is given, so we are going to apply NP chart. Understood? Let's start with illustration number 10. From the factory, there are 200 taken as a daily. Let's write down the dates. 1, 2, 3, 4, 5, 6, 8, 10, 11, 12, 14, 15, 18, 19 and 21. Now, defective ring is given. 18, 10, 20, 20, 26, 12, 15, 17, 18, 10, 20, 20, 26, then it will come 20 again, then 26, 12, 15, 17, 31, 34, 32, 13 and 10. We have to put a NP chart. So for the NP chart we need the NP bar. So total of NP upon M. So total of the number of the defective items. So total of the D is equals to 304. So NP bar is equals to sigma n upon m. 304 upon 15, it will come 20.26. Right? NP bar is equals to NP bar upon n. So 20 upon 26 upon n is equals to 200. Here n is equals to 200 and m is equals to 15. So 20.26 upon 200, it will come 0.101. Right? Now let's apply the control limits. Before, first we find out 1 minus P bar. So 1 minus 0.101 is equals to 0.899. Control limits, central line is equals to NP bar. NP bar is equals to 20.26. Then upper control limit is equals to NP bar plus 3 under root NP bar 1 minus P bar. So let's put the values. NP bar is equals to NP bar is equals to 20.26 plus 3 into under root NP bar is equals to 20.26 into 0.899. Let's solve the values. So 20.26 into 0.899 and under root multiply with 3, it will come 12.81. So 20.26 plus 12.81, it will come 33.07. It is upper control limit. Now lower control limits. NP bar minus 3 under root NP bar 1 minus P bar. So 20.26 minus this value 12.81. 7.45. 7.45. Let's make a chart of the NP chart. On the x-axis we are taken the dates, and on the y-axis we are taken the NP. For the first date, there is a defective ring is 18. Sorry, before we put central line limit is equals to 20.26. So around 20 we are going to make a line. Central line. Upper control limit is 33. So it will come over here. Upper control limit. Lower control limit is 7.45. Lower control limit. Let's put all the points. For the first, $18 rings, so it will come over here. For the second date, it's a 10. For third, 20. Fourth, 20. Fifth, 26. For the sixth, 28. 28, 10, 12, 12, 15, 14, 31, 'I have left out 11 over here, so here it will come 11, 12, 14, 15, 18, 19, then 21. At 11 we have marked it like 15. At 12 it is on 17. At a 14, 31, at a 15, 34, for 18, 32, for 19, 13, for 21, it's a 10. Let's join all the points together and how this is a NP chart look like. And you can see that the 1 point, it's in out of control, it's beyond the upper control limit, right? So at the 15th date, on the 15th date, the process is out of control. There is a NP chart. Understood? P chart and NP chart. Thank you.